Okay, so we are discussing about the mind map here. So what is the mind map about? We have seen unsupervised learning. What is there in unsupervised learning? So what did we discuss? Agglomerative clustering, that is hierarchical clustering. And in non-hierarchical, I have k-means. If I want to just overcome the drawbacks, I have DB scan. And we have also seen association rules. Now let's see what is present in this particular mind map. So here clustering or segmentation, here you have the first one hierarchical, which consists of the top down and bottom up approach. You can go through these things. Okay, the second one that we have is non-hierarchical or partition-based clustering, in which you have k-means, k-medians, k-medioids, and k-modes. So when you have data which is not categorical, then if I want to perform k-means clustering, then I can simply go for k-modes. If I have outliers in my data, then I can simply go for medians. So this is what you have different types of methods. Along with these, you also have k-means plus plus. K-means plus plus is nothing but in this, there is some difference between k-means and k-means plus plus. As I told in k-means, we are randomly choosing all the centroids. But in here, it will randomly choose only the first centroid, and remaining everything else, it will choose based on the maximum distance. That is somewhat different when compared with this. That is nothing but the partition-based clustering, which is non-hierarchical clustering. And then you have the next one, that is density-based clustering. So what is there in density? That is DB scan. See here. So DB scan, what is there here? This is a density-based spatial clustering of applications with noise. It works well for non-spherical shapes. And there are two parameters. One is EPS, second one is minimum points. If it is satisfying the requirement or greater than or equal to minimum points, that is called a core point. And if it is not satisfying the minimum points, but it is having a core point nearby as a neighbor, it is called as a border point. And noise point, which is not a core point nor a border point. This is what we have seen in density based. And we have also discussed about what? Association rules. So association rules, what we have, see here, association rules is also called as market basket analysis or affinity analysis or relationship mining. And in order to overcome the drawback, here you have a priori algorithm, which consists of different things like the performance measures, which you have support, confidence, lift ratio, leverage, and conviction. So support, as I told, which talks about frequency, it ranges between 0 and 1. And confidence here, it ranges between 0 and 1. And lift ratio, it ranges, or wherever the association is strong, the value of lift will be greater than 1. And leverage here is ranging between -1 to +1. And this conviction will range again between 0 and infinity. These are the different things present in association rules. So what are the operators that I have used for these in RapidMiner Studio? For the first one, that is agglomerative, I have an algorithm called as agglomerative clustering. This is the algorithm, or this is the operator present. For k-means, I have k-means. For DB scan, I have DB scan. And for association rules, I have FP growth and create association rules. These are operators that in order to just perform this in 2 minutes without writing any code in RapidMiner. That is about unsupervised learning. Fine. Unsupervised learning is fine. Then what about supervised learning? Unsupervised learning is fine. Then what about supervised learning? How can I understand about supervised learning? So we have already discussed about supervised learning. What is there in supervised learning? What did we discuss about? So here, supervised learning is where you have both input and output variable. You have input variables and you have output variable, within which you will do the prediction, that is supervised learning. In here, what happens here? This is also called as predictive modeling. Unsupervised is also called as descriptive modeling. Here, you have some historical data that you will randomly split into two different data sets. One is training data set and second one is validation data set or validation data. So you have some historical data. Here you are randomly splitting this into training and validation. And within this training, we will take mostly 80% or 70% of our data, and the remaining everything will be in validation. So in the training data set, what we do, we will just build a model. How? On 80% of this historical data, I will apply my machine learning algorithm. After that, I will just get a math equation or a mathematical equation. What is this mathematical equation talks about? This talks about the relationship between output variable and input variables. Okay, fine. I got my mathematical equation. Then what? Then I will apply this mathematical equation on my left data, which I've kept aside, that is validation data. This is also called as development data. So on this validation data, in this, I don't have an output variable, there is only input. After that, I will apply this mathematical equation and I will get some predicted outcome. So here, what happens? Here, the actual values are compared with the predicted values. Based on that, I will get the accuracy. If the accuracy that I got here is very good, then I will use this mathematical equation on my future data or new data as well. Then I will predict my outcome. This is what happens in supervised machine learning or supervised modeling or supervised data mining. Anything is fine. This is what happens in supervised. Within which, what did we discuss in our previous session? We have discussed naive Bayes, and we have also discussed the next one, k nearest neighbors. So what is naive Bayes and what is k nearest neighbors? What did we discuss about it and how to perform those in RapidMiner Studio? And what are the next supervised machine learning algorithms there? We will discuss about everything here. So supervised machine learning, what we have discussed up to now, we have discussed or we have seen naive Bayes algorithm. So first one is naive Bayes. What is naive Bayes? What is there here? So this is basically a probability based technique. So in this, we have seen joint probability, conditional probability, so on. What is joint probability? So you have a lot of mails, within which I told like 80% of the mails are not spam and 20% are spam. Now I will bring a new event or a new email and I want to check that is lottery and I want to check what is the probability that this particular email gets into spam. What is the probability that this gets into not spam? This is called as the concept called as joint probability. So naive Bayes is a probability-based technique in which we have seen joint probability, conditional probability, and so on. Now, how to do this in RapidMiner Studio? How to do or how to perform naive Bayes in RapidMiner Studio? How to do it? So let me open the RapidMiner Studio for you and we will work on it. So here, I'm going to my RapidMiner Studio here, and this is the old process that we have created, which is association rules. Now I will just delete this thing. Okay, I will delete this one. How? Just select this entire thing and delete in your keyboard. Okay, now what I want to perform, I want to perform one of the supervised machine learning algorithm, that is naive Bayes. On which data set? I want to apply it on iris data set. So iris, I'm not connecting it from here. I'm directly connecting from the data set that I already have. That is the CSV, I guess. So I'm using the operator read CSV. In order to connect with your CSV file, you have brought the operator, that is fine. Then what you have to do again? After bringing in your operator, what you have to do? You have to load your data by double-clicking on your operator. So simply double-click on your operator. Check it out which of the data source that you want to use. I want to use Fisher's iris dataset, which is already present in my local machine. I'm not using the iris dataset, which is already there in the default datasets. I'm connecting with this one and I'll click on next. So here, no problem is there. You can check it out at the bottom and again click on next. And here, these are the data that is present in my particular data set. And I don't want to format any columns. I'll click on finish. So here's my CSV file. If you want to check out the number of records and columns, you can check it out how to, you have to make the connections and execute the process. Fine. Out of which I have 150 records and 5 columns. And here, as I told, this is a supervised machine learning algorithm. You should have an output variable. But in my data set, there is no special attribute that is labeled as green. Now what I do is, I will just use the operator to make it as an output, which is set role. Take it into the process. Take it into the process. And if you want to customize your operator, you have to go for the parameters. So what is it? See here. I'm going to the parameters of set role operator. I will edit my list here and I want to check out the species as my output variable. Output is nothing but label. So species is my label. What is it? Species is my label. And after that, I'll click on apply. Okay, I've set it out and execute the process and check whether it is in green color or not. So see, this is in green color because this is now a label because that is an output variable. Okay, fine. Now what to do? Now, as this is a supervised machine learning algorithm, I have to randomly split my data. In order to split your data, you have to use the operator here, which is split data operator. Take this operator into the process. Take the operator split data into the process. After that, I want to edit my list here, or I want to split it into two. What are the two? So I will add an entry. One is 70% of my data, that is 0.7. I will add one more entry, that is 0.3, which is 30%. I have split the data into two. One is 70% and second one is 30%. And click on OK. Now I got two sets of data, which is one is the training set and second one is testing set. And on the training data set, I have to apply the machine learning algorithm. What is the algorithm that we have been discussed? That is naive Bayes. Take the naive Bayes algorithm into the process. Take the naive Bayes algorithm into the process. After this, I have to measure the performance. How? The accuracy by using the operator, that is apply model, in which you have to apply this on the remaining 30% of the data as well. So splitting the data, 70% goes into the machine learning algorithm. I will get the model. After the rest of the 30%, I have to make it into apply model. Check out here. 70% goes into naive Bayes and remaining 30% goes into the model. And here, I want to get the response of naive Bayes first. Okay, sorry. Naive Bayes algorithm response needs to be first. And after that, these connections are present. These needs to be again response. Check it out, everybody. So this is my CSV file, which is Fisher's Iris data set, and in which I don't have an output variable. So I have just used the operator set role. Here, my output variable I've taken as species, which I have checked out in my parameters. Set role parameters, species as label. After that, split the data. I have split my data into two. One is 70%, second one is 30%. If you want to get this, you have to click on add entry. Okay. After splitting the data, the 70% of my data, the first part goes into naive Bayes algorithm and I will get the response. Okay. And after that, the 30% of the split data goes into the apply model and I will execute the process after making the connections. Okay. Now everything is fine. Click on this part to execute the process. Now check out what happened. So here is my split data, how the data got splitted. Check it out here. The first one. So split data here. This is split data. And after that, apply model. What is there in apply model? So confidence of species length, all those things are present here. This is apply model. And after that, this naive Bayes. So 4 distributions are there. In this 4 distributions are there and 4 distributions are there. And if you want to measure the performance, you have to use the operator performance classification here. So out of, if you just keep this recommended operators, it will recommend you whatever that you want to use. Take out the performance operator as well and check the performance if you want. So this operator input needs to be the apply model output. The apply model output needs to be this input and this is connected fine. And these needs to be connected here. This is how you have to establish the connection to get the accuracy, execute the process. Now check out the accuracy performance. So this particular thing that you have created, the model is 97% accurate, which is very nice. You can use this on the future data as well. This is how you can perform the naive Bayes algorithm in RapidMiner Studio. So what did I do? CSV file Fisher's Iris data set and label, I've kept the output variable as species and I've splitted my data 70% as 1 and 30% as 1. I applied the naive Bayes algorithm on 70% of my data and I have get into the apply model. Remaining 30% directly applies the model. And if I want to check the accuracy, the model has to be connected with this operator performance classification and check the connections properly and execute the process. This is what happens in naive-Bayes algorithm. So we will have a quick 10-minute break and we will just check out the next supervised learning algorithm, that is KNN. Okay, we will be back in 10 minutes, everybody. Okay, so everybody, let's continue with the session. So we have discussed about the naive Bayes, and the second one that we have already completed, which is KNN algorithm, which is K nearest neighbors. So what is it? First, let me just open the mind map for you. So here the next one that we are about to discuss is KNN algorithm, that is K nearest neighbors. So what is this? What happens here? So here, as we talked about before, there is a concept called as hyperparameter. Based on the values of K, I'm changing it multiple times. I can experiment with a lot of different K values. I can take 1, I can take 3, I can take 5 and so on. But mostly it is suggested to prefer only the odd number of values, because if I want to check out which one is nearer to it, if it is even number of values, then it will be difficult for me. I will get confused. So always choose the K values mostly as odd numbers. Now I will change the K values. I'll experiment with this. So I can call this as a hyperparameter. So the kind of model which you're not building using any prediction models or any machine learning. I'm just doing this based on majority. That is called as a baseline model. I've just talked about this as well before. So if you're not going to create any model, and if I'm just using the majority to create a model or predict it, that is called as baseline model. So when you have an output variable, that is categorical, and this is having two classes. Now you will go with majority in baseline model. Now what about the output variable is categorical, but it is having multiple classes, more than 2. Then what? Then you can either go with the majority or you can go with the higher proportion of data. So this is what is K nearest neighbors, another supervised machine learning algorithm. So for this, if I want to just do this in RapidMiner, how to do it? How to perform K nearest neighbors, how to do it in RapidMiner Studio? Which operator I have to use for this particular supervised machine learning algorithm. So let's check it out. Let me just erase this and move back to the application, which is RapidMiner Studio. So this is the one, this is the process which I've previously created. I'm just going to delete this process. Just select it and delete the process. Okay, the process got deleted. Now I want to work for, or I want to just create a process in order to show you the example for the algorithm, that is K nearest neighbors. What is the operator? Which is the data set that I'm going to use? Let's check it out. So the same thing that I'm going to use, that is Fisher's Irish data set, which is a CSV file that is present in my local machine. What is the data set? That is Irish data set itself. You can use it from here or your own. Anything is fine. So I'm using the one which is present in my particular machine, which is a CSV. So I'm using the operator read CSV here. If you want to load with or connect with the data, what you have to do? You have to double click on the operator and you have to check out which particular data set you are going to use. That is Fisher's Iris data. And click on next. Here, check it out whether you want to just format anything or whether you are having any warnings or such. I don't have anything such. So I don't have any problem. So I'll go for next. After that, here, if you see here, this is the formatting thing. If you want to check it out, you can check it out. I'm not changing anything. Simply, I will click on finish. So my dataset got loaded or connected. If I want to just understand the data, the number of records in columns, I have to make the connection and execute the process. Okay, the process execution is done. Now what to do? Now I have to set the role. What is that? As this is a supervised machine learning algorithm, I should have an output variable. If you want to declare something as an output variable, which operator you have to go for? That is set role operator. So take your set role operator into the process. Now what? I want to customize my operator using the parameter. So use this option and I want my output variable, that is species, that is label. Species is my output variable. I have just made this in the like with the help of parameters of set role operator and click on apply at the bottom. Okay, I've set the role. Now what? Now you have an operator called as cross validation. Split the data, you can use that, or K cross validation, anything is fine. So check it out, cross validation. So take this data set into the process. So you have to observe this one. So here, read CSV is an Irish data set within which I don't have an output variable that was set before. So I have used set role operator within which I have set the output variable as species. Fine. Now, I want to split the data. Why? Because this is a supervised machine learning algorithm. You can either go for the before thing, that is split data, or cross validation. Anything is fine. Now what? Now double click on this operator, cross validation. You can check out here, the part 1 is training and the part 2 is testing. In part 1, what we do? We will apply the model. In the training data, on the training data, we will apply the model. Which model we are applying? That is KNN, because we are currently working on the algorithm KNN. Take your machine learning algorithm into the training. Now establish the connection. How? Before training data set comes into KNN algorithm, and it will give the output which is connected to this. After that, what? After I have to apply the model which is present in the testing, I will use the operator apply model because I've got the model. I want to check the accuracy. So apply model, just check the connections again. Testing data to this one, model to model. Fine. Now what? Now I have to check the performance. How to check the performance? Which one you have to use? You have to use so you have different types of performance. You can check it out here. But we are not working on clustering. This is not segmentation. What is this one? This is not segmentation. This is classification. So I'll go for performance classification. Take it here. After that, what? Now, just connect. And also here, make the connection performance, example testing. After making the connections, this is fine. After, go back to the process. How to go back to the process? Here you have process which is in blue color. Click on it. You will get into the process. Now here also you have to make the connections to get the output. This one to response, this one to response, testing one again to response, and performance also to response. Now make the connections properly. Okay, this is not connected. Make the connections properly. Check out all the connections. So if you click on this, double click on this, you will get this again. If you click on again process, you will get here. Double click on this, you will get again. Just check out the connections and execute the process. Now here it is showing accuracy. That is, this particular data set is showing the accuracy of 96%. But before in naive base, I got 97%, out of which I will prefer the most one, which is 97 rate. So you can check out the accuracy in simple manner using different types of machine learning algorithms, and you can just decide which algorithm you should go for. This is about the second supervised learning algorithm, that is K nearest neighbors. Let's check out what is present there. Before, I will just explain this process to you one more time because this cross validation is a new operator that we are using. So I've just connected with the Fisher's Iris dataset. I've connected with the Fisher's Iris dataset. Within this is a supervised algorithm. I should have an output variable that is for mandatory. An output variable, what is that? Species is my output variable, that is label. Species is my output variable. Then what? That I have done with the help of the operator called as set role. Set role is the operator. After setting everything properly, I have to divide my historical data into two parts, training and testing. So you can use either split data in RapidMiner Studio. You can use either split data or you can use the cross validation operator as well. Before in naive base, I've shown you split data. Now I'm showing cross validation. So use cross validation here, double click on it. You will get training and testing separately. So as you already know, the model or algorithm needs to be in the training phase. So the algorithm that we are discussing is KNN. So take the operator KNN into training. After applying the model or after applying the machine learning algorithm, you should get some model or you will get the model which talks about the accuracy. So apply the operator, apply model in the testing phase. And if you want to measure the performance, you have to use performance classification. This is not clustering. That is why you have to go for classification. If it is regression, you can go for regression. So this is classification. So I'm going for classification. Okay. After that, you have to go back to the process here by clicking on it. And you have to establish the connections between cross validation and response put. After making the connections, execute the process. You will get the accuracy. Based on that, you can decide which algorithm you can go for. This is the second supervised machine learning algorithm, that is KNN, K nearest neighbors. Let's check out what is present in the mind map. So this is supervised learning, which is machine learning primer. Here we will split the data into training, validation, and testing, and we will compare it. And what is there in supervised learning? In supervised learning, it is also called as predictive modeling. We have classification models. What is classification models? So in this, you have again different types. We talked about this before. Binary classification is nothing but, for suppose your mail is spam or not spam. Spam or not spam. Two classes are there. That is binary classification. If you have more than two classes, for suppose mail, I have social, I have promotion, I have spam, and so on. More than two classes, that is multi-class. Multi-label is nothing but a mail can be present in both spam as well as promotion. It can be present in both spam as well as maybe primary. Whatever it is present in multiple labels. That is called multi-label classification. If it is giving you as output as a categorical data, spam, not spam, that is categorical classification output. If it is talking about probability, so 80% of the mails are spam, 20% are not spam. This is category probability classification output. This comes under classification models. Now coming to the second one, that is shallow machine learning models. What is there in here? Check it out. So here, the first one that we have is naive-based or probabilistic learning. So naive-based, you have multiple names. So here for regularization technique, we will use Laplace estimator that we have discussed before. In this, we have also seen joint probability and conditional probability. And coming to the K nearest neighbors, it is also called as lazy learning. It is also called multiple names. See here. Memory-based reasoning, example-based reasoning, instance-based reasoning, and case-based reasoning. So here we will just use the technique of K values. This is hyperparameter. We have completed these two. Now we have to discuss about the third one, that is decision tree, which is also one of the shallow machine learning model present in supervised machine learning algorithms. So what about this decision tree? What is happening in the decision tree? So in order to understand about this topic, let's move on to the folder in which we have the PPT regarding this thing. So we have discussed up to here, KNN is done. Now we are about to discuss the decision tree. So this is the PPT of your decision tree. So here is our decision tree. So as a part of data mining, we have understood the supervised machine learning. And now we are supposed to discuss about this decision tree. Okay. So what is this decision tree? So I have already talked about a word called as non-parametric. What is non-parametric? What is non-parametric? So here, so this particular algorithms that we have discussed before, what is a K and then all those things, it will work, or this particular modeling, which is decision tree, it will work for both scenarios. So as I told before, you have to understand which algorithm will work for which type of data. Based on that, we will do the discretization and encoding. For both the cases of numerical and categorical, you will use naive Bayes and KNN as well as decision tree. It applies for most of the different categories or numericals. Anything is fine. Now, all the three algorithms that we are discussing are called as non-parametric. So, what is the difference between non-parametric and parametric? We will see in the coming session when we talk about regression. Okay. Now, if the parameters are learned based on the word, I will tell you in a single statement. If the parameters are learned by a model, you can use those parameters for your future purpose or future prediction. If you do not learn those parameters, those are called as non-parametric algorithms, in which we have naive Bayes, KNN, and decision tree. So coming to the next one that we are about to discuss, the new one, that is decision tree. Decision tree is an algorithm which is having a lot of different versions. Like you have ID3, you have after the ID3, you have C4.5, C5, the C5.0. So you have different versions that you have to get an understanding about. The latest version or the current version is C50. Okay, now we are going to talk about the decision tree, which is one of the other technique present in supervised learning. So what are decision trees? what we have here. So let's check out what is present in the slides. So here, so decision tree here, this is a rule-based technique. It is also called as non-parametric technique or hierarchical model. So here, in this particular module, we are about to cover about what are decision trees, how to build a decision tree, and what do you mean by a greedy algorithm, and what is the best build decision tree, and what is attribute selection, in that what is information gain. So these are what we are about to discuss in this particular module. So first of all, you have what is a decision tree? What are decision trees? What are decision trees? So a decision tree is a tree-like structure in which internal node represents test on an attribute, each branch represents outcome of the test, and each leaf node represents the class label. What is this? Within a decision tree, you will have a path. What is it? Within a decision tree, you will have a path. Path will be from root node to the leaf node. For suppose, imagine this is the first node, which is root node. And every decision tree will have a path. If they are the last, these are called as leaf nodes. So the path from root node to leaf node is nothing but a path. Or a way, anything is fine. So from root to leaf, the path is called as a classification rule. From root node to the leaf node, the path is called as a classification rule. Classification rule. Now, the nodes are of three types. There are three types of nodes. What are those? So let's try to understand the difference between the nodes. What are the three types of nodes? The first one is root node. The second one you have is branch node. And the third one that we have is leaf node. Suppose in your training data, you have a lot of columns or features. You have a data set. It is having a lot of different columns or features. As we are talking about the supervised algorithm decision tree, you should have input variable as well as output. You are having a lot, okay? Now, these input variables are also called as features. These input variables are also called as features, or we can also call them as attributes or dimensions. Anything is fine. And the output variable is also called as label or target variable. Anything is fine. Out of all the features, which one we need to select as the root node? Suppose you have a gender column. So gender column, you have mostly male and female. So out of those, if I want to just select gender as a root node, I will select gender as the root node. And I have two nodes, branch nodes, that is male and female. And after that, I have to categorize. Based on what? Based on a condition, maybe. I will just tell male, whoever age is less than, the next one I will talk about is age. Age less than or equal to 30, greater than or equal to 30. I want to get it here. So this is about the simple decision tree. Now, here I've got confused, like whether I have to take gender or male or age, which column I have to take it as a root node. The node which is present at the start of your decision tree is called as a root node. The node which is present at the start of your decision tree is called as the root node. And out of all the features which needs to be selected as a root node, which we have to understand. Now, what are the features when should be considered as internal nodes? And how do we decide that? If I take the point as age here, at what point I have to divide it? At 30 or what value? What, based on what I have to choose these conditions? Which one I have to choose it as a branch node? Which one I have to take it as a root node? And the last node which is present in the decision tree, which is the terminal node, is called as a leaf node. And until when do you continue this splitting process? So this is dividing and conquering. That is why the decision tree is also called as divide and conquer method. What are decision trees? How can you understand about this one? How can I understand about this? So decision tree is one of the other supervised machine learning algorithm present. It is called as divide and conquer. And here, basically, we have three different types of nodes. At the start of your decision tree, whatever the node is present, that is root node. And the leaf node is nothing but the terminal node. And the center nodes are called as branch nodes. And I have to get an understanding of which out of all the columns input variables I have, I have to choose as a root node. And which one needs to be selected in between, and what is the condition, the value, how much I should take. I have to get an understanding about all of these things. So let us see what is present in the slide. So a path from the root to leaf is called as a classification rule. A decision tree consists of 3 types of nodes. What are those? Root node, branch node, and leaf node. Now coming to the next topic, that is how to build a decision tree. How we have to build a decision tree. What is the main theme of building a decision tree? How I have to build it? So see here, check it out. So here, we use training data to build the model. So there is an example given to you that is basically the kids want to play outside. That is about the data. Check it out here. So here, we have to building a model. But while building a model, we have to consider what are those tree generator or decision tree generator determines which variable to split at a node, what will be the value, where I have to stop the process, where I have to assign the terminal nodes as a label. I have to understand or get an understanding about all these things. See here, this is the basic structure of your decision tree, the root node, and whatever the small dots are there that are leaf nodes. If it is a big dot, that is a branch node that needs to be further splitted again until you get everything as leaf nodes. This is where your decision tree stops. So we have to get an understanding where I have to stop it, which node is the terminal node or leaf node, and where I have to take the condition based on which value. These things I need to consider when I'm working on a decision tree. Now, here you have given a data set. So see here, decision tree, here you have an example. The kids want to play outside. The kids want to play outside. Now what here? Here, as this is a machine learning algorithm supervised, you have to understand which is the output variable and which are all the input variables. In this example, whether he wants to play or not, the play is nothing but the target variable or the output variable or the dependent variable. The play is called as the dependent or target or output variable or label variable. Anything is fine. Now what? The root node is here at the bottom. Okay. And the leaves are here. These path is called as classification rules. Now the nodes at which your decision tree needs to be stopped or it is stopping is called as a leaf node. Suppose you have a variable called as outlook. Suppose you have a variable called as outlook. Okay, here it is present. See here. Okay, here. So suppose you have a variable called as outlook. So outlook means, see, you have a data set within which you have an output variable that is play, whether he wants to play or don't play. That will be your output. And imagine you have maybe 50 records and this is your output variable. You have one more thing that got, which is outlook, whether that is, okay, check it out. There are different things present in outlook. What are those? Whether it is sunny or cloudy or it is rainy. These are the 3 things present in outlook, which are present for all the records. All the records. Now here what? You have a variable called as outlook. Now, out of 14 people or kids present, how many wants to play and how many don't want to play? First, we have to understand that. So see here, out of 14 people, 9 wants to play and 5 don't want to play. 5 records is having don't play as output and 9 records is having play as output. Fine. Now I got a new record, out of which I have to understand out of 9 play, how many are playing in sunny, how many are playing in cloudy, how many are playing in rainy, and out of 5 don't play, how many are not playing in sunny, cloudy and rainy. I have to understand. So you have another input. Okay, see here. So out of which 9, 2 here, 4 here and 3. 4, 7, 9. And out of 5, 3, 0 and 2, 5. So this is divided. And then what? You have another one which is called as a temperature. So you are checking the one more input variable, that is temperature. So temperature here, he's taking the condition whether the temperature is less than or equal to 30 degrees centigrades or it is greater than 30 degrees centigrade. So windy is another output. So see here. So for rainy again you have windy, and windy again I'm checking the outputs. This is how everything goes on until everything is having a leaf node. So here everything needs to be play and don't play only. So check it out. For sunny, I have temperature. For rainy, I have windy. And for cloudy, I don't have anything. So everything is not dividing further. I don't have anything to divide further. That is where this particular decision tree stops. That is one of the example provided here, which is based on the the dependent variable play. Okay, here, see here. Now, what is it? Playing outside 14 are there, out of which play is the dependent variable or target variable. So now we are presenting this in the form of reverse manner, which is present before bottom to top. And here this is top to bottom, which is easy to understand. So again, the same thing windy, and again the same thing temperature. This is what the decision tree look like. We reverse it and we will understand it clearly. Now, there is another example to understand this decision tree. The decision tree algorithm works on some concept called as greedy algorithm. What is it? The decision tree algorithm works on some concept called as greedy algorithm. This is one of the basic algorithm present. This is one of the basic algorithm present. Based on what we are working on this algorithm? Based on top-down recursive divide and conquer manner. What I can call this as, okay, divide and conquer. So this is based on top-down recursive divide and conquer manner. So what is it? So let's see what is present in the slide. This is the basic algorithm. And a tree is constructed in a top-down recursive divide and conquer manner. We will see what is it in an example. At start, all the training examples are at the root. At start, all the training examples are at the root. Attributes are categorical. If continuous, they are discretized in advanced. Input data is partitioned based on selected attributes. The test attributes at each node are selected on the basis of heuristic or statistical measure, that is information gain. We will talk about everything clearly. Let's just see what is present here. Okay. So conditions for stopping the partition. All samples for a given node belongs to the same class. There are no remaining attributes for future partitioning. Majority voting is employed for classifying the leaf. There are no samples left. So when I am reading the theory, you won't get an understanding properly. So I will just provide you this particular theoretical in the form of a practical example, in the form of a use case. Let's check out what is there here in the second example provided. So this is the heading is provided as sample data. Okay. So here you have different customers. Okay. Here you have customers who are registered in your website. What is this data about? Imagine there is a data set, sample data. This is nothing but about the customers who are registered in your website. They want to purchase a computer. For suppose you have customers who are just registered in your website and they want to purchase a computer. And you, as an e-commerce company, you want to predict whether that customer will buy the computer or not. Then what you have to do in order to predict this output? What you have to do? So you have here the output variable, that is buys computer, whether a person is buying the computer or not. That is your output variable or target variable or label variable here. Okay. And apart from that output variable, you have rest of the other input variables as well. What are those? This is your output. This is your input 1, input 2, input 3, and input 4. There are 4 input variables or records of different customers, whatever it is. So what is that? You have age, which is continuous. Okay. And you have age with how many levels? How many levels are there? One is less than or equal to 30. One is in between 31 to 40. One is greater than 40. So this is a column with 3 levels. And age is having very limited values. So this I can call it as a factor. So age is a factor with the limited values. And what about income? Income is also not having much of the values. This is also a factor. This is the one with, again, 3 levels: high, medium, and low. And student, you have different students, whether that particular customer is a student or not, yes or no. And credit rating, whether it is fair or excellent. And whether he is buying the computer or not. Now, for now, see here. But now assume the root node to be your student. Assume you are taking student as your root node. Now what? Now what? As you have seen, few of the customers are students and few are not students. Then how many are there? The levels, 2 levels. What are those? One is yes, he's a student, and another one is no, he's not a student. So check it out what is present in the slide. So you have no and you have yes. Based on that, you have got these outputs. How you got these outputs? How did you get it? So no. So you have totally how many columns? You have age column. You have income column. You have student column and the credit rating and whether he is buying the computer or not. Okay. So here class is nothing but output variable. Just like check it out like that. Now here see age. How am I getting age here? How am I getting age here? See here, I have written age here as well as here. How am I getting? Based on the students here. So check out what is present in the previous slide. So here, if you observe, when I take student as my root node, here you have only 2 levels. One is yes and second one is no. Now, whatever the students that comes under S, these records. Just give me a second. So here, what are the records that are having yes? This one is also another one, and he's also a student. This R9 is also a student, R10, R11, and R13. These are students. Now, who are not students out of this? R1 is not a student, R2, R3, R4, and then this one, R8, R12, and R14. These are yellow color are not students and pink color are students. When I just want to divide this according to the student root node, I have further columns. What are those? What are the further columns? That is, first one is age, income, credit rating, and buys computer or not. So here, these are the values that is present in your next sheet that I have shown before. So when I take student as a root node, you will have all these values. Now what? After that, I have chosen now income as my branch node or internal node. Anything is fine. So as I talked before, income is a factor having 3 levels. What are those levels? High, moderate, and low. Now, based on this, I will again have the level C here. Step 2, I'm taking the internal node as income. No, income is there. And then yes, income is there. And within the income, if I take income, again, I have high and medium. Here, high, low, and medium. Why is it? We will check out. Student, no, I have only high and medium. Let's check what is there. Okay, see here, what are those we are talking about? Student, no. Student, no, no, no. Student is no here, sorry, and no here as well as here. Now let's check income. It is high, 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 medium, 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 and medium. So here in the records, who are not students, they don't have income moderate. They only have 2 levels. One is high and medium. That is why it is showing only high and medium. So this you have to get an understanding about when you understand your data. So what is that? First, I've taken student as my root node. And after that, I've taken income as my leaf node. And here, check it out. High is 1, medium is 1. Low, medium, and high again 1. So once again, you can split it. This is called as a top-down recursive divide and conquer. Why is it? We are dividing from top to bottom and we are dividing recursively one after the other. And that is divide and conquer method. That is called as this is based on top-down recursive divide and conquer method or approach. Recursively, we are doing it. So until where do I have to split this data? Where do I have to stop this? When you run a decision tree, you will have a stopping criteria present. What is that? If you have a single node, you will stop it. Until when you have to stop it. Check it out. Check out here. The third step is he is taking the next one as the condition. See here. So medium and high. He is taking medium whether he is yes or yes. See here. So why we got here yes and yes? Why? Why we got yes and yes? Because we don't have anything further to divide here. Here, if you see, there is a stopping criteria. If you are having only a single record, or if you are having a class which is having both the same values, then you don't need to further divide this. Until when you have to stop splitting the decision tree, until you get everything as a leaf node, then where you have to stop it for the records which are single or for the records which is having everything same. Here nothing, all are not same. Here all are not same. Here all are not same. So I have to further split these data. This I can change, just take it as yes and yes because those are leaf nodes now. Now, step 4, I have to take another condition based on age column. So age and also the credit rating. So age is having 2 levels and this is also having 2 levels. This is also having credit rating and check it out. So now you have to decide again, do you want to delete this further or not? So here there is no need to split because only one record is present. Here no need to split because 2 values are same. Here you need to split because these are different. Here you need to split because this is also different. Here again this is same, no need to split. Here again these are different, you have to split. For those you have to split what? Student, no, income. For age 31 to 40 I have to split. And again no, income, medium. For both of fair and excellent I have to just split it. And for coming to student, he is a student and income is low, I have to split for excellent. These are the things that I'm going to split in my future. See here. Student, income is there, age is there, and then credit rating is there. Now here, student, no, income, which is high, age 31 to 40, I have to split it. So see, this is what we are doing in the process. And until when you are stopping it, you have a single node or you have all the values same, then I have to stop my decision tree process. If it is pressing S and U, then you have to continue to split. So that is why this is called as top-down recursive divide and conquer approach. Your output variable will never be a node in this. Here you don't have any node as output variable. You have only the input variables as nodes. So only based on the input variables you are doing the prediction. So you won't have or you won't take any output node as your roof node or a branch node or a leaf node. You won't take it as a node. Okay. Now, when you look at this data, what are the classification rules that you have understood? What do you mean by classification rule? As I told before, the path between any roof node to leaf node is a classification rule. So you have totally different number of classification rules here. How can I do the prediction using this one? How can I do the prediction? So this further needs to be splitted, right? We will see up to the splitting. Then we will discuss about how to predict. So here everything is done. Now I don't need to split it. Now what? Now what did I predict? What did I understood about the prediction? If I got a new customer and I have to analyze based on the decision tree and I have to predict whether he will buy a computer or not. Based on this decision tree, how to just get that conclusion. So yes, here, if the customer is a student and if the customer is not a student and if he is getting an income of high and if his age is less than or equal to 30, then he will not buy a computer. If he is not a student, he is getting income of high, and if his age is in between 31 to 40, he will most likely to buy a computer. These are the different classification rules that you got from this decision tree. Based on that, you will predict your future data. Understand what is that? So these are the prediction rules present. Check it out. So if he's not a student, if he's getting high income and age is less than or equal to 30, he will not buy a computer. These are the different classification rules present. These are the different classification rules present. Okay. Now you can just check out. If I take another variable as a root node, what happens? You can check those as well. Here I have taken student as a root node. You can take income as a root node, age as a root node, anything is fine. So instead of student, if you take income as a root node, out of different features, I have to understand or how can I understand which column need to be chosen as a root node? Which needs to be chosen as a root node? Okay. So here see, decision tree root node, if I take it as income, check it out. Now consider another approach to build the decision tree. Let's take the attribute income as the root node. So income, again, you have three levels: high, moderate, and low. High, medium or moderate, anything is fine, and low. Based on that, I further classified my data. Then what? Then I can take one more, maybe age. Age I have taken, and here I have taken student and CR. So age, and I've got these, and you have to check whether you have to further split the data or not. I've got it. Now everything needs to be yes. And again, this needs to be split because these are different values. Again, they are splitted again. Again, you have different yes and no. Again, these needs to be splitted again. This again needs to be split because yes and no, two different values I got. So this is ultimately how I got my decision tree when I take income as my root node. So now you have to decide whether you want to take student as the root node or income as your root node. You have to understand that one. How? How? So you have something. Okay, decision tree is basically an algorithm which works on larger data sets. So that is something we are about to talk about. Based on what we are selecting the root node. That is based on the concept called as greedy algorithm. So these are the classification rules you got when you take income as your root node. So the path from the root node to the leaf node is called as a classification rules. Totally, I got 10. Before I got 11. Now, there is an approach based on what we are selecting the root node. That is called as greedy approach or greedy algorithm. To decide which input values or attributes need to be the root node, we have to calculate something called as entropy. What is it? So we have an approach called as greedy approach. What is this approach useful for? It is useful for us to make us understand out of all the input variables, which needs to be chosen as the root node. Okay. So in order to understand this concept, we have to calculate something called as entropy. So what is this entropy? So this entropy is nothing but a measure of impurity. Entropy is a measure of impurity, or I can also call it as disorder. It is a measure of impurity or disorder. Now, if you have higher entropy, then you can call it as you have more impurity in your data set. If you have high entropy value, if you have high entropy value, then you can call this as you are having very high impurities in your data set. You are having very high impurities in your data set. Now, we will find the entropy of the output variables. Any input variables or features, if it forces you to take a decision, if they force you to take a decision, for suppose you are tossing a coin, okay? For suppose what? I'm just flipping a coin or tossing a coin, anything is fine. Out of which I have 50% chance that the output variable is heads. I have 50% chance that the output variable is tails. For suppose if a person purchases a computer, whether he will purchase or not, 50% is he will purchase the computer. 50% probability is that the person will not purchase the computer. In these kind of scenarios where we have 50% probability, the impurity will be greater than or equal, impurity will be equal to 1. What is it? When you have such kind of scenarios where we have 50-50 probability, then you can call there as the impurity or the entropy value that is equals to 1. We will check out what is present in the slide. We want to use the attribute that does not bell job splitting up the training data set. What can this be measured? This is impurity. We use entropy and information gain. Entropy is a measure of disorder or impurity. We will find the entropy of the output values of a set of training instance. If the output variable is 50-50, then the impurity is equals to 1. And what else? And what else? This impurity value, it ranges in between 0 to 1. this impurity ranges in between 0 to 1, which means 0 is nothing but pure, you're not having any errors in your data. 1 is nothing but impure. Based on that, you are having the range of values. So we will talk about 25% and 75%, all those things later. So see, check it out here. So if the output is 0, then the purity is also 0. If the output variable is split 25% and 75%, we will discuss about it later. After that, the entropy, you have the next one that we have is information gain. What is information gain? What is it? What is information gain? So the information gain is based on decrease in entropy after a data split is split on an attribute. It is based on the decrease in entropy. You need to ensure to calculate the information gain for every column present in your data, and which of the column would be the root node, and which of the column will give you the highest information gain. That will be called as the most homogeneous branch. What is it, everybody? So here the information gain is nothing but based on the decrease in entropy. So here you need to ensure that every column you are calculating the information gain. You have to calculate for every column. Based on that, I have to select which column needs to be the root node. And this particular information gain is also called as the most homogeneous branch because the similarity is more. And what else? And what else? Constructing a decision tree is about finding attribute that returns the highest information gain, that is most homogeneous branches. And what is information gain? What can we talk about information gain attribute selection? What can we talk about this? Before talking about this, let's have a quick 10-minute break and we will get back.
Next na అయిపోయేది కదా.
Okay, everybody, let's continue with the session. So the next one that we are about to discuss is information gain. So here we will just discuss about the theory and also we will see the use case and understand everything. So here, select the attribute with the highest information gain. So these things we have to understand before moving on to that. We will just see what is what and then we will come here. So what is what? So here we need to calculate something called as expected information, which is called as entropy. Here we need to calculate something called as entropy information. Expected information. So here we need to calculate expected information, which I can call it as entropy. Based on that entropy, then I will calculate what is the information needed. Based on the information, based on this, I will calculate information needed. So what is that expected information? How can I calculate this expected information? This expected information is also called as entropy before. This expected information is also called as entropy before. So when we subtract that expected information from the information needed, then I will get something called as information gain. What is it? Information gain, nothing but expected information, which is entropy before, minus the information needed. This is nothing but the information gain which we need in order to understand this concept of decision tree. Okay, information needed is also called as entropy after. What is it? Information needed is also called as entropy after. Expected information is also called as entropy before. The difference between these two is called as information gain. Now, what is the use case for this? How can I understand this concept? Here. So, see the use case for this. The calculation looks very simple, but it is not very simple to see yet. But let's discuss about this. Okay, here, this is the same example that we have taken before. So let's talk about entropy, how to get the outputs or the values present, how to get it. So here, entropy is nothing but impurity. We talked about that before. Before going to that, here you have input variable and you have 4 output variables. Or we will also check out what is that, maybe the second example, let me check. Okay, fine. Okay, here is the use case, which is the same as before. For suppose, if you are having 3 inputs, like ball size and something like that, let me show you in the form of an Excel so that it will be easy for you. So let me open the Excel file and just create a sample data set so that it will be easy for you to understand. Data set is not there. Just let me check out. Okay, let me open the Excel file for you. So here is my Excel file in which I will create the data set and I will explain it to you the example of this particular decision tree. But suppose imagine you have maybe 5 records, 1, 2, 3, 4, and 5. So I will just name this column as serial number. And I have ball size. 3 inputs are there. That is, the first one is ball size. And the second one is ball color. And the third one I have is price. And after this, as this is a supervised machine learning algorithm, I should have one dependent variable, which is an output variable. So output variable, I will just name it as useful for play. This is my output variable. So what are those? These three are input variables, and this is my output. I will just give some random records. Okay, give here. I will give 10, 1, 50, 100, 1000. And ball color, I will give everything as red itself. And price, I will randomly take the price, maybe 5, 1, 5, 5, and 10. Now, whether it is useful to play or not, it is the output variable. If it is yes, write yes. If it is yes, write yes. If it is useful to play, yes. If it is not useful, then write no. This is my data. This is my sample data. So what is this? What did you understand here? So here in this data set, you have three input values, x1. Okay, x1, that is ball size, ball color, and price. And you have one output variable, that is whether it is useful to play or not. Now what? Based on the inputs, I have to say whether the ball is useful to play or not. That is the output variable. So what is the formula to find out information gain? What is the formula that is there to find out information gain? Information gain is nothing but entropy before minus entropy after. And entropy, I told you before, it is a measure of impurity, which you already know. Before talking about entropy, let's talk about information theory. So if you see something like the sun rises in east, okay, I'll write it here, see. If there is a statement like the sun rises in the east, here there is a statement that is sun rises in the east. So you already know this is the default one. Everybody knows it. Everybody knows it. So what? In this, do you find any information content? Do you find anything like that? So here, what is the probability and what is the info content? What is the probability and what is the information content? For suppose you have another one, maybe you have another one, maybe there was an earthquake in Hyderabad. This is another. What is it and what is the information gain? How can I have that one? How can I understand probability and information content? So you already know about the sun rises in the east. If you see this like particular statement, everybody knows this. So I'll just take the probability of sun rising in the east is 1. And the information gain is 0 because I am not getting any new information from this particular statement. However, if I see the second one, there was an earthquake in Hyderabad. So the chances or the probability for the earthquake to be coming very low. So I will take the probability as low. And what about the information content? I'm just learning a new thing. That is the high. So the information that appears in sorry, I'm just losing my internet connection multiple times today. Okay, sorry for that. So what we are discussing about here, we talked about the inversely proportional thing. The information gained or the information content is always inversely proportional to the probability of event. In order to ease this calculation, they have used the log calculation. Now, if you take this to the numerator, if I take this probability to the numerator, what it will happen? Minus of log square, so log 2 probability, log probability of event base 2. This is called as information content. This is called as information content. What is this? How did I calculate this one? Based on the statement, what did I understand? Here, always the information for every event is inversely proportional to the probability of event. In order to ease the calculation, I have applied log. Log of 1 by probability of every event. Now, further how to calculate it? I will bring this probability to the numerator minus log of probability of every event to the base 2. This is called as information content. And we have also discussed about the mean. What do you mean by mean? Mean, you already know about mean. What is the mean? Mean is nothing but the average value. What do you mean by average value? How to calculate the average value? So here, average is nothing but sum of all the numerical values or the values divided by the number of observations, which means sigma I is equals to 1 to n of xi divided by total number. This is how I will calculate the mean. And we have also discussed about expected mean. What is expected mean? Expected mean means we are multiplying every random value with its respective probability. So expected mean, I can write it as sigma I is equals to 1 to n, every individual value xi into probability of xi. So this is how I will calculate the expected mean. So when your data is uncertain, then we will go for probability. And you can also go with expected mean. Now, with the help of same logic, I will apply that to the information content. If you want expected information content, similar kind of formula is given. So this is information gain or information content, which you already know. And what about the expected information content? Expected information content is called as entropy, which can be written as what? Minus sigma I is equals to 1 to n log of probability of every event base 2 into probability of every event. This is xi, the mean value. Here the mean is this one into the probability of every variable. This is expected information content, which is entropy. How can I write this as? Is equals to minus sigma I is equals to 1 to n pi into log 2 base pi. This is called as information, which is called as entropy. This is what it is present in your slides. So entropy is used to measure impurity. If you say entropy is 1, it is not having any impurity. So if I write it as 1 minus entropy, then that is called a measure of purity, which is nothing but accuracy. This is nothing but accuracy. So entropy is nothing but a measure of impurity. And if I write 1 minus entropy, that is nothing but accuracy, which means the pure data. These formulas you have to remember. Now coming to the use case. What can I write here? What can I understand about here? So here, coming to the use case, information gain. What is the formula of information gain? Information gain is equals to entropy before minus entropy after. So in order to get this, I have to calculate before as well as after. Now, based on the output variable, you can see there are only 2 classes coming. So I can call this as a 2-class classification problem or 2-class classification. Now, how to write the formula for the information gain? How can I write the formula? So here I will write the formula that we have discussed before. Minus sigma I is equals to 1 to 2 because the n is 2 because I have only 2 classes, and p of probability of the first value xi into log base 2 probability of again xi. This is the formula that we have got before, that is entropy. So here, how can I write this according to this concept? So how I can write this as minus probability of x1 into log probability of x1 base 2 minus probability of x2 into log probability of x2. Okay, so x1 is nothing but yes and x2 is nothing but no. Now, what is the probability of x1 and x2? How to find out this one? So, probability of x1, which means whether the value is yes or not, I have to find it. So, out of 5, how many are yes? 3 are yes. The probability is number of interested events divided by total number of events. And how many times you have yes? 3 and 5 are the total. If I want to calculate the probability of x2, that is how many are no. Out of 5, 2 are no. This is the probability of the second one. Now I will substitute this in the formula. What I will get? Minus 3.5 into log of 3 by 5 base 2 and minus 2 by 5 into log 2 by 5 base 2. If I calculate the calculation for this, I will get the output. When you solve this, maybe I will get it as the output. Approximately, I have the value 0.970 something. Now, we got the entropy before. I got this entropy before. Now, what about entropy after? If I calculate entropy after, then I will get the information gain. How to calculate entropy after? So, for suppose if I create a decision tree based on the ball size, I will take ball size and ball sizes maybe 10, 1, 50, 100 and 1000. I will have a lot of different outputs. So what is it? If I take the ball size as my root node and I have here, maybe I will take the ball size is less than or equal to 50 or it is greater than 50. And you have to whether it is yes or no. Then check it out. How many are yes and how many are no. Now, what your decision tree does is it will sort your ball size data. These data will be sorted. How? Like 1 and 10, 50, 100 and 1000. Now the decision tree sorts the data of the ball size. If the values are less than or equal to 50 or values of 50, based on that, it will give the values. Now I have only 2 classes, so this is the rule. Let's say the first value. What is the first value? The first value, the actual value is yes. And when I compare it, I will get the predicted values after the model building, right? After the decision tree, I will get the predicted values. I have to check it whether they are correct or not. Now, check it out. 10. 10 is less than or equal to 50 or 1 is less than or equal to 50. That is yes. So, yes is the actual value. This is yes. And y is again the predicted value. Both are matching. And for the second one, 10 is less than or equal to 50. That is predicted value is yes. And what is the actual value? Actual value is also yes. This is matching. And coming to the third one, 50 is less than or equal to 50. Yes. Again, predicted and actual values are matching. But coming to the next one, 100 is not less than or equal to 50. So the predicted value is no. And the actual is also no. Again, these are matching. And the last one also will be matching. Now, we need to calculate the entropy on left as well as the entropy on right. When I calculate both, I will get the entropy after. When I calculate both only, I will get the entropy after. So we need to calculate first on the right side and then on the left side. Anything is fine. Now, how to calculate for the right side? How many are there? Totally 2 are there. Now, probability of x1 I have to calculate, which is yes. And probability of x2 I have to calculate, which is no. Out of 2, how many yes are there? 0. So 0. How many no are there? 2. 2 by 2 is 1. This is the probability values on the right side. Now substitute it in the same formula like before. Is equals to minus 0 into something 0. So everything will be 0. The probability on the right side, the entropy on the right is 0. Now I have to calculate on the left also. Now for this y, what is the output? 3r y is 3 by 3, that is 1. And x2, probability of x2, 0. Because 0 are no's. So this is also will become 0. So entropy right and left are all 0. Now how to calculate entropy after? Entropy after is equals to the first probability that I got 3.5 into entropy left plus 2.5 into entropy right. So everything is 0, 0, 0. Something into 0 is 0. So the entropy after is 0. I got entropy before and I got entropy after. Now, how to calculate the information gain? Entropy before, that is 0.97 something, minus entropy after 0. So the information gain is 0.97 something. You may wonder, why did I take only 50 as my output? If you take ball size, you know this is a two-class classification problem. The easy way to sort the data and taking the center value. So here, always take the centermost value in your data, which is 50, as your condition. If you want to mostly work with different experiments, go for 1, the minimum value less than or equal to 1 and greater than 1. But mostly prefer to take the middle value. In that way, you will get the information gain for every particular record. So you can do this for every particular column. Information gain, I have to find it for every column, not only for the ball size. I have to find out for ball color, I have to find out for price and so on. How to find out for the next one, ball color? In the similar manner of the ball size, I want to find out for ball color as well. How to find out for ball color? See here, I will take the ball color as my root node. And what is the color? There is nothing different. Both are red only. Two class, so both are red. So here, S and no, both are there. Both are there. Now everything is red. I cannot segregate. So here you have 50% chance that they may be yes and that they may be no. Now how to calculate the probability? As I told, if you are having 50-50 probability, then the probability I will calculate it as 1. Another point you have to remember is, if you have a column with no variation, like there is no variation here, this is a zero variance feature, we can simply go for removal of that column. So there is no need to calculate for ball color. You can directly go for price. So I will take price as my root node. Now what is the middle value? If I sort this 1, 5, 5, 5 and 10, middle is 5. So less than or equal to 5 is the first condition and greater than 5 is the second condition. Based on that, again, do the same process. Left and right, you have to calculate. So here, the expected value, the first one is 1. 1 less than or equal to 5, yes. So this is also yes matching. The second one, 5. 5 is also less than or equal to 5, yes and yes matching. Yes and yes matching. And coming to the fourth one, 5. 5 should come under yes only, but this is coming under no. This is not matching. Why not equal to n? This is misclassification. But coming to the last one, this is fine. Now, you have to calculate the entropy on the left and entropy on the right. How to calculate entropy on the left-hand side and right-hand side? So here, entropy before and after, if I calculate, so that only I will get the information gain. If not, I won't get it. You already know the formulas. You have to substitute those here. And at last, for all the columns, you will get the information gain. Just like that, you have to calculate for every other column in order to understand the concept called as information gain, which is the most important thing when it comes to the decision trees. This is in order to talk about a simple example, because in the slides there is a bigger example. I don't want you to get confused. So this is how we will talk about decision trees. So see here, he has taken some example within which he is working. Information gain for every column: age column, income column, student column, and then credit rating column. And these are the classification rules that he got. Classification rule is nothing but the path from root node to the leaf node. Okay. And here, ID3, as I told, there are different versions. The current version is C5.0. And these are the quick things that you have to remember. So in this particular module, what we have discussed about another supervised machine learning algorithm, that is decision tree. So decision tree is usually useful for useful in order to get prediction of output variable. In that, we have seen an example of the output variable, whether the kids are going for the play or not, they are playing or not, based on temperature, based on wind, summer, or something. All those things we have calculated, or we have created a decision tree. But based on the information gain value or the entropy value, we will decide which needs to be the root node. Which needs to be the root node, we will calculate based on the entropy value. Entropy, what is entropy? Entropy is a measure of impurity. If I take 1 minus entropy, that is nothing but accuracy. And in order to calculate information gain, that is nothing but expected information, that is entropy before minus entropy after. Entropy after, if you want to get the value of it, you have to calculate entropy right as well as entropy left. When you calculate all those things, you will get an understanding about the information gain. Based on that, you will understand which needs to be your root node. So this is about it. In tomorrow's session, we will discuss about how to do it in RapidMiner Studio. And also we will start discussing about the next topic, that is regression topic, linear regression and logistic regression. We will see this in tomorrow's session, which is exactly at 10 o'clock. I hope this session is helpful for you, everybody. Thank you so much. Good morning, everybody. So this is another session regarding RapidMiner. So we will have a quick understanding of what we have discussed up to now. Then we will move on to the next topic. So before moving on to the new topic, we have to see what we have here, map, which is CRISP-MLQ methodology, in which we have seen understanding and data preparation. And coming to the model building, we are currently in the stage which is model building. In business understanding that we have to do, that is business understanding, in which you have different things that you have to focus on, which is first your business problem, and also you have to get an idea about your objective and what are your constraints present, your success criteria as well. What is your business success criteria? Things you have: data understanding, data preparation, and model building. So in business understanding, what we have the first thing that we have to understand our business problem and access criteria. And here you have also seen the name called as project charter in every project. And then you have the second step, data collection, as well as the data types. So in data collection, you have to understand whether you are using the data that you have got from primary data sources or secondary data sources. So you are getting an understanding of your data, whether you are getting it from primary data sources or secondary. And coming to the data types, you have to understand what are the different data types present. So there may be discrete, they may be continuous, they may be structured, of different data types. Everything you have to get an understanding in which stage, which is data understanding. So business understanding is about the business problem statements like business problem, business objective, business constraint, and success criteria. Coming to the data understanding, this is all about data collection and data types. Okay, this is fine. Now, what about data preparation? What is there in data preparation? So data preparation consists of, again, you have EDA, which stands for exploratory data analysis, and you also have data pre-processing. Exploratory data analysis and data pre-processing. So EDA consists of, again, 4 business moments. That is first moment business decision, which is measures of central tendency. EDA consists of 4 business moments, within which the first one is measures of central tendency. And the second moment of business decision is measures of dispersion. And the third moment business decision is skewness. And the fourth moment is kurtosis. So here measures of central tendency, here this includes again mean, median, and mode. You already know about these things. Mean is the average. Median is the centermost value. Of dispersion, it consists of standard deviation, variance, and range. So here you will get the basic understanding about your data. This mode is calculated or mostly preferred for categorical columns. When you have a categorical column, you can't calculate mean or median. You can go for mode. So depending upon the type of column, you can go for different types of business movements that you can applicable for. And coming to this Kunis talks about asymmetry of distribution. And what about kurtosis? This talks about the peakedness of a distribution. So whether it is normally distributed data or non-normal. If it is normally distributed data, then what is the skewness value? What is the kurtosis value? Everything we have seen in the EDA, exploratory data analysis or descriptive statistics. After that, you have the next step, that is data pre-processing. So what is data pre-processing? Basically, it is nothing but cleaning your data. You have raw data in which you have to clean the data using different data pre-processing steps. So what are the different pre-processing steps present? What are included in it? You have, first of all, cleaning and organizing the data. Cleaning and organizing the data. And what else? You have typecasting. Typecasting is nothing but changing one data type into another data type and to use in RapidMiner Studio. For typecasting, you have different types of operators like numerical to nominal, numeric to nominal, or maybe numeric to date, or numeric to binomial, polynomial. You have different operators present in RapidMiner Studio. You can use it for typecasting, depending upon your purpose. And the next thing that you have is duplicate records. So how to handle duplicate records? In order to remove them, you have an operator called as remove duplicates. How you will handle duplicates? And then the next important, identify the outliers using different techniques like winsorization, or you can go for 3R technique, which consists of 3 R's of appearing these outliers. You can go for nothing but remove outliers and IQR for detect outliers operator. Okay, that is that. Another one present in data pre-processing. And apart from these, what else are there? Outliers are fine. Missing values. The most important thing is missing values. So, okay, we are talking about missing values. The next one that we have is missing values. So how to deal with missing values and why you are having missing values? For that, you have a concept called as variance. So there are 3 types of variance: missing completely at random. We have seen all these things before. Based on it, we will apply any of the technique that we have. Okay, we have variance here, out of which we will choose based on the reason of missing values. And then we have imputation methods. What is imputation? Imputation is nothing but replacing the missing values with some logical value. It may be either mean or median or mode or random. Depending upon your purpose, you can use any of the imputational method that you have. And you can also go for deleting the missing values. In deleting, again, you have case-wise deletion and pair-wise deletion. And in order to handle the missing values, you have an operator called as replace missing values or impute missing values. You have different types of operators. You can go through any of those. And also you have in data pre-processing discretization. So discretization is what? Converting continuous values or variables into discrete variables or discrete values. For that, you have an operator discretize, or you have this typecasting operators as well. Anything you can use. And coming to the encoding, encoding is the opposite of it. Here we have categorical columns. We are converting it into numerical columns, within which again we have a lot of different types. One-hot encoding or binary encoding, label encoding, which is also called as ordinal encoding. And also you have dummy variable creations. Coming to the discretization, here also you have a lot binarization. You have again binning, and you also have rounding, which we have already seen. Okay, this is about data preparation, which consists of both EDA and data preprocessing. And coming to the model building, we are currently in this stage, which is model building. After we are done with cleaning our data, we will create or build a model. How we will build a model? You will have two namings that we have seen before, that is unsupervised learning and then supervised learning. We have discussed about this. Let's have a brief explanation about these, and we will move on to the topics. Okay, unsupervised learning. What is unsupervised and what is supervised? We have already discussed about this. In unsupervised, we will have only input variable. There is no output variable. Y is unknown in unsupervised learning. Okay, so this is also called as descriptive modeling because we are not predicting anything here. This is called as descriptive modeling. And here what happens? Here you have some historical data. On historical data, we will apply the unsupervised machine learning algorithms. After applying machine learning algorithms, we will get some rules or patterns. Basically, we will do all these things in order to understand the patterns in the data, right? We will understand the rules and patterns. Based on these rules and patterns, I will apply this on new data or future data or test data. Okay, once I apply this, I will get the predicted outcome. This is what happens in unsupervised learning. And then what? In unsupervised learning, again, you have different types of algorithms. What are those different types of algorithms present in unsupervised learning? We have seen few of those and how to do it in RapidMiner Studio as well. So here, in unsupervised machine learning algorithm or unsupervised algorithms, what we have discussed in unsupervised. So we have discussed the first one, that is agglomerative clustering. The first one that we have discussed is hierarchical, in which we have agglomerative clustering. And then we have seen non-hierarchical clustering, which consists of k-means algorithm. In order to overcome the drawbacks of hierarchical clustering and k-means, we have DB scan as well. This is density based. And apart from those, we have also seen association rules. Apart from these, we have also seen association rules. So these are what we have discussed in unsupervised learning. So coming to agglomerative clustering, what is there in agglomerative clustering? Why we are learning all these techniques? So in agglomerative clustering, we basically calculate or create the clusters based on distance. We will create a distance matrix. Based on that, we will just create the clusters in agglomerative clustering. Here, what happens? For suppose you have a set of data in which you have 6 records or 5 records or 7, anything is fine. So I have totally 7 records in step 0 or step 1. In this step 0, I will consider each and every record as an individual cluster. Based on the distance matrix, whichever the distance is similar, I will group them as a cluster. Cluster is nothing but grouping the similar data points. Okay, here basically I will get at last a very large cluster. So this step-by-step process is called as agglomerative clustering. This step-by-step process is called as agglomerative clustering. Okay, fine. But when you are having a single column, which means a single variable, when you are having a single variable, then how can you do the clustering? When you have a single variable, how to do the clustering? With the help of box plot. When you have 2 variables, then how to do the clustering? With the help of a scatter plot. When you have a single variable, I can do the clustering with the help of box plot. When I have two variables, I can do with the help of scatter plot. Now, when I have more than two variables, then what? Then I will use a mechanism called as multivariate distance. Then I will use a mechanism called as multivariate distance, within which what we will compute. So here we will compute the distance between records, and we will also compute the distance between record and cluster or a group, and also distance between clusters. So what is the ultimate goal or objective of a clustering or clustering process? In cluster, the objective is we have to minimize the variation happening or the dissimilarity, whatever it is. We have already discussed in a cluster, always the similarity is high and the distance between the data points is always less, which means what? The dissimilarity is very low. That is our main objective of doing the clustering, to minimize the variation between the data points. So here you have these concepts if you want to find out the distance between different things like records or clusters. And also again, when you want to find out distance between records, it will be based on the variable, whether it is numerical or categorical. So for suppose, if you want to measure the distance between the records for continuous variable, then what? Then you will obviously go for Euclidean distance. We have already seen this. Euclidean distance is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square. Apart from Euclidean distance, you can also go for Manhattan and also Mahalanobis. You can go for any of it when you have continuous variable, when you have continuous data. For suppose you have discrete data or categorical data, which is binary, which means two categories are there. In such case, what you will do? How you will calculate the distance? For this, again, you have different methods like binary Euclidean distance, and you also have simple matching coefficient, and you also have Jacquard's index. These are the things that we have when you have categorical binary data to find the distance. First, suppose I have mixed data. In my data set, I have categorical columns as well as numerical columns together. Then how to do the clustering for mixed data? For mixed data, I have three steps. The first one is I have to normalize the numerical columns. We have already seen normalization, standardization, and robust scaling in the scaling methods in data preprocessing. When you want to make it scale-free and unitless, you can go for any of these techniques. So in normalization, what happens? The minimum value will be 0 and the maximum value will be 1. So here, when I have mixed data, I have 3 steps to be done. I want to do these 3 steps. The first one is I have to normalize my numerical columns, which means all the columns need to be in the form of zeros and ones, which means the minimum should be 0 and the maximum should be 1. And the second step is I have to perform one-hot encoding on categorical data. So you have categorical columns. Categorical columns can be converted into numerical with the help of encoding technique, in which I have one-hot encoding. After that, for all the values, I have to find out the distance using Euclidean distance. These are the 3 steps that you have to follow when you have mixed type of data in order to do the clustering. So apart from this, what you have, you also have Gomer's general dissimilarity coefficient. This is one more technique present. Okay, so this is one more technique present. This is what is to find distance between two records or distance between records. But when I want to find out the distance between different clusters, I have to find out distance between different clusters. Then what to do? For that, I have a concept called as linkage functions. In linkage functions, again, we have multiple types: single linkage, complete linkage, and then what? Average linkage and centroid linkage. These are the different ways of calculating or doing the clustering process depending upon the type of variable. This is about the concept called as agglomerative clustering. This is one of the unsupervised algorithm present. So we will see everything how to do it in RapidMiner Studio as well. So let me open the application. Let me just search for the application. Just give it a moment. Just give it a second, everybody. So here's my RapidMiner Studio. Let me delete everything. So we are about to discuss how to do everything that we have discussed in RapidMiner Studio, which is the tool we are concentrating on. So what is this RapidMiner Studio? Why we have to use it? What is the purpose of using this? So as we talked about before, this RapidMiner tool is called as a no-code development platform for data mining. So you already know about data mining. Data mining is a process which helps to analyze the large amount of data in order to understand or uncover the meaningful patterns or insights that will be useful for the businesses to make informed decisions. In which you have a lot of different tasks like what we have discussed before: association, clustering, classification, and then forecasting, estimation. You have different things present. But if I want to do this in separate tool like Python and all, I have to write a code. But there is a specific tool called as RapidMiner Studio or RapidMiner, in which I can perform all these tasks without writing any code. That is why this is called as a no-code development platform for data mining. So without writing code, how can I perform it? By using different components present, out of which I'm going to use the operators, the main thing, which means I have built-in operators present here. I'm going to use it depending upon the task that I'm going to perform. Okay, so in here, we are about to discuss how to perform agglomerative clustering by using which operator. And if I want to measure the performance, how to do it, everything we will discuss. So here, coming to here, first of all, in order to connect with the operator, I should have some data that I want to work with. So here, I will just connect with empty cars. I have the cars data set, which is the basic one, which is a CSV file. I want to connect it only for temporary purpose. I don't want to store it in my repository. So I'll go for using the operator called as read CSV because my file is a CSV file. So I'm taking this operator into the process. We have also talked about the interface or components in this particular RapidMiner Studio. What are the components present? What is the purpose? We have already discussed about it. So here, these are the operators which I have to take it into the process. So read CSV, what CSV file I want to connect here? I want to connect here the empty cards data set. So double click on it. In your local machine, where is that present? Just select your particular location. Here I have empty cars data set. So I'm going to connect with that. So here's my data set. You can see all the columns present. So if you have any formatting problems, you can check it out at the bottom. It will be showing as a warning. But here right now, everything is fine. I don't have any problems in my data. Now I'll click on next. And here again, if I want to format, I can format it. I can change the name of the column. I can remove the column and I can change the data type. I can do all the formatting things here and I can click on finish. Now I got my data. If I want to see the data, I have to connect the ports and I have to execute my process. After executing the process, the output can be shown in the view called as results view. Okay, up to here, this is fine. And if you see here at the bottom, there are 32 examples, which means there are 32 records. Here, as I told before, records are called as examples and columns are called as attributes. If you have any attribute or column which is dependent or independent, it will be as a special attribute, which is a label one. Target variable. You can just label it. That is called a special attribute. But for now, this is having 32 records and 11 columns. Okay, fine. Now what I have to perform? I have to perform agglomerative clustering. So if you want to select the columns, I don't want to perform clustering on all the data present. I want to select only few columns. Then you can go for select attributes. But I am not selecting any specific columns. I'm directly going to use the operator, which is agglomerative clustering, because I want to perform agglomerative clustering here. I'm taking this into the process. So check it out. Every operator needs to be connected with each other. As I told before, different methods present, you can check it out here. Single linkage, complete linkage, average linkage based on Euclidean distance or what, you can check it out here. So I'm not changing anything. I'm simply leaving it as is. I'm connecting these and I will execute the process. See here, this is the example set. After clustering, how is it going to look like? This is hierarchical cluster model clustering. So total, I got 63 clusters created, but I think that they are a lot. 63 is a lot. So if you want to see them in the graphical manner, you have a chart called as dendrogram. How the clustering is happening, you can check it out here. Dendrogram. So here, if you see, this is not clear because of the lot of clusters. If you want to give as many clusters as you want, you can just use the operator called as flattened clustering. If you want to see the description of every operator, how to use it, what are the inputs, what are the outputs, you can check how. Right click on any operator that you want to work with and click on the first option, show operator information, and check the description. So this operator creates a flat clustering model from the given clustering model because it will reduce or it will just creates the clusters as many as you want. How? Take this into the process. After taking it into the process, now what happens? First, you have to establish the connections properly. And after that, if you want to customize your operators, you have a special component called as parameters. So here, out of 63, I want only 5 clusters to be created and execute the process. So now see, there are only 5 clusters that are forming because I have just written as 5 number of clusters. So this is how you can just use the operator agglomerative clustering operator in order to perform the specific type of clustering called as agglomerative clustering. Fine, that is fine. Okay, in unsupervised learning, what about the other algorithms present and how to use it or which operator to use in RapidMiner Studio? So apart from agglomerative, which is hierarchical clustering, we have also discussed about the second one called as non-hierarchical clustering. And within which I have also shown you the k-means clustering. So k-means clustering. Here k is a hyperparameter. Why? Because we will change or we can use or we can define the k different values like 1 or 2 or 3. Based on that, I can get different outputs. So here what? First, suppose, imagine, I will take an example here. First, suppose I have 25 records in my data. In my data, I have 25 records. Out of 25 records, I want to create 3 clusters, which means the k value you are giving it manually. I want to create k clusters, which means 3 clusters in my case. So what happens here in k-means clustering, it will randomly select the centroids of the 3 clusters. It will happen randomly. So what I do out of all the data points, I'll randomly choose C1, C2, and C3, the 3 centroids. And then I have 25 records. For those, I have to measure or I have to find out the distance between each centroid to each data point. I have to measure the distance between each centroid to each data point. Based on that, I will do the clustering here in k-means. Here, if you observe the first record, out of D11, D21, D31, I found that D21 is the one which is having less distance. So what I do is, I will just take the first record and I will cluster it with the centroid 2, the cluster 2, which is C2. Why? Because the distance is less. So when I do this for every record, the clusters will get changed. If the clusters are changing, automatically if I find the average, the centroids will also change. If I am getting new centers, then the distance from the data points will also change. If the distance changes again, then the clusters again changes. So this happens repeated multiple number of times until when you have to stop this process. Until the clusters does not alter or it does not converge. Up to then, you have to perform these steps repeatedly. This is what happens in the second type of clustering present, that is non-hierarchical clustering, in which k-means clustering. So in RapidMiner Studio, how to work on this k-means clustering? Which operator is used here? Let me show it to you. So agglomerative clustering is hierarchical clustering, and non-hierarchical clustering, which consists of the next one, that is k-means clustering. So here, how to just perform this in RapidMiner Studio? Let me go back to the application. So here, I'm going to delete the process. Whatever that I've created, just draw a box simply and delete in the keyboard. And as I told before, we not only import the data sources from our local machine or databases here, we can also use the inbuilt data sets which are already there. Where there are the inbuilt data sets, where can I see them? So you have different components in which you have repository panel on the left-hand side. Within that, you have a lot of different folders. Just open samples folder, and then in that you have data subfolder. When you open all these things, you will get the inbuilt data sets present in your RapidMiner Studio. So what is there? Like, where are those? How can I check it out? Here is your repository panel on the left-hand side. And here is your samples folder. And here is your data subfolder, within which I'm going to use the data set, that is iris data set. You already have or familiar with this data set, so I'm using with this, or I'm just working on it. The concept of k-means clustering. So iris data set is there. If I want to see the number of records or number of columns, I have to execute my process. So out of which I have 150 records, which means examples, and 4 regular columns and 2 special columns. Now what? Now what? Now what is that? So here, you not only check out the data, but you can also check out different types present. What are the different types means? What do you mean by different types? Which means you can go for statistics, you can go for visualizations, anything is fine. Okay, these are the columns present. Now what to do? Now, I want to normalize. For suppose if I want to normalize my data, what is the operator for normalization? That is normalize operator. So I will take it so that the process will be easy because the data is in a single scale. So normalization. So here I'm not changing anything. And after that, I will use the operator called as k-means clustering, because we are working on k-means algorithm. K-means clustering. So I've taken this k-means clustering into the process and the connections are fine. If you want to just change your operator or customize your operator, you have to go for parameters. So you can check out the k value. I'm not changing anything for now. And after performing the clustering, I have to measure my performance. So I will take the operator called as cluster distance performance, because we are measuring the performance based on the distance in clusters. So I will take this operator into the process. After taking the operator into the process, check out the connections. Yeah, this is fine. Cluster is connected here. And after that, if you want to measure the performance, you can measure it. Check out all these things, the connections, and execute the process. So input connection is not there here. So here, if you check it out, the total number of items 150 are divided into 4 or 5 clusters, 0 to 4. If you want to check out how it is looking like or which records coming in which cluster, you can check out the folder view. And in the graphical manner, you can check out the graph or the centroid table. What are the different centroids that you are getting? As I told, the centroids are chosen randomly here. I have taken K as 5. That is why it is creating 5 clusters. This is how you will perform the k-means clustering in RapidMiner Studio using the operator k-means. This is another one present in unsupervised learning. Apart from this, you have again one more thing present, that is dbScan. What is the next one present? The next one that we have is dbScan. So as the name indicates, this is based on density. Here, this is a density-based clustering algorithm. Here, we will create the clusters based on the density. For suppose I have a data set here, I have data points here, and I have data points here. Now, if I do the k-means clustering or hierarchical clustering, which is agglomerative, this will be based on distance. But when I want to create based on a density, I can go for the clustering called as dbScan. So in dbScan, what is there? In dbScan, the main important thing is you have to focus only on 2 parameters. What are those 2 parameters that you have to focus on? The first one is EPS, which means the radius. And the second one is minimum points. So these are the 2 parameters that you have to concentrate on when we are talking about dbScan. So here, for suppose I have a data set. Within that data set, I have taken, for suppose, radius as 5 centimeters and the minimum points as 2. Based on the requirements of my parameters, I will analyze my data and I will categorize the data points into 3 types. One is core point. Second one is border point or boundary point. Anything is fine. And the third one you have is noise point. Based on what I'm dividing the data points here? Based on the 2 parameters that I have, that is radius and minimum points. If I check out from this data point, 5 centimeters radius, what are all the data points present? If it is satisfying the minimum number of points that I've taken here, if it is satisfying that requirement, whether it is greater than or equal to minimum points, then that data point is called as a core point. That data point is called as a core point. If 2 core points are near together, I can just make it as a cluster. And what about border point? If I have a data point in which I don't have minimum number of points present, if the minimum points are less than the parameter minimum points, and if it is having a core point as neighbor, then I can call that point as a border point or boundary point. So if I have a core point and a border point near together, I can make it as a cluster. And whatever which are not falling either in core point or border point are called as noise points. This is how we will categorize the data based on the 2 parameters, and we will just do the clustering process. That is dbScan. So in order to overcome the drawbacks present in here, you have again one more thing present, that is HDBScan, that is hierarchical dbScan, in which you will have some additional parameters. This is what you have the next one present in unsupervised learning, that is dbScan method or dbScan algorithm. Now, how to perform this dbScan in RapidMiner Studio? What is the operator that I have to use in order to perform this type of clustering in RapidMiner Studio? Let me open the application for you. So this is the process that I've previously created. If I want to save it and go for the new one, I can go for it. But I'm not saving it, so I'm just deleting the process that I've created. And I will create a new one. Now, I don't want to use any data that I have already present in my RapidMiner Studio, or I don't want to import any data from my local machine. I don't want to do either of those. Then what to do? Then I have a special operator that is called as generate data. You have an operator called as generate attributes, generate data, anything is present. You have to go through all these things depending upon your purpose. I'm going to generate my data. Okay. So here I have to give the parameters or customize my operators through parameters according to my requirement. So here are the parameters. What am I doing? So you can choose the target function. My function, I'm choosing it here is 3-ring clusters because we are working on clustering. So I will just take randomly 3-ring clusters. So in 3-ring clusters, always the number of attributes are 2 only. So you have to get an understanding of this theory, then you can use it according to your purpose. Okay, fine. This is done. If you want to see the data, you have to make the connection and execute the process. So check it out. I have given, I want one label because 3-ring clusters are present. And then I want 2 attributes to be there. One label and 2 attributes. And then what? Now I want to normalize my data because if you see the data that is not present in proper format, some are negative, some are huge positive, some are less. So I want to normalize my data. So normalization and standardization are different. In normalization, the minimum will be 0 and maximum will be 1. In terms of standardization, the mean will be 0 and standard deviation is 1. But I want to do the normalization here. So what is the operator? Normalize is my operator. Just take it into the process. After that, I have to check out the parameters of normalize because I want to go for minimum as 0 and maximum as 1, not the standardization method. So I have to check out the parameters of normalize operator and I want to change this method into range transformation. I have to use the method here that is range transformation so that here you can see the minimum is 0 and the maximum is 1, which is normalization. After performing the normalization, I have to obviously do the clustering. So what is the algorithm or the clustering thing that we are discussing? That is DB scan. You can use directly the operator called as DB scan. So take your operator into the process. If you want to customize your operator, you can check it out here. See, there are 2 parameters present. The first one is radius and second one is minimum points. So check out the output once you execute the process. So here's my thing present here. So, but the data points here are very less. That is why I can't see the clustering process properly. So what I do is I'll go over here and I will just generate my data of larger numbers. Instead of 100, I will take 10,000. Okay. That is up to you. How many records you want, examples, you can check out in the parameters. I will execute the process now. For 1,000 examples that I have, it will just do the clustering process based on the density that is called as DB scan. It is taking a while, just give it a second. After that, you will get the output. If you want to see the original as well, you can see the original as well. So check out here. Here you have the clustering for which you have an additional column. Each record belongs to which cluster it has shown here. And go to the visualization and check out your cluster. So as the data points are very huge, I can see the clusters clearly now, the blue color, orange color, and green color. Based on what it is divided, based on the density, because this is a density-based method. This is how you have to perform the method or the clustering called as DB scan. If you want to see the original, you have to just check the original to response and execute the process. You can do whatever you want. This is nothing but the next one that we have discussed, that is DB scan, the density-based method. Check out the visualizations whether there is any difference present here. Just give it a second. It is loading because I have taken 1,000 examples here. This is my clustering process. Okay, so here this is the clustering here, and this is normalization. If you want to see the result history, you can check it out here. This is how you will perform the DB scan in RapidMiner Studio using the operator DB scan. Why we are learning this tool? Because we are not writing any code. I'm just understanding what is what, and I am using different operators which is having or which is inbuiltly present here for different specific purpose. Each operator is designed for a specific purpose. For cleaning your data, you have separate operators. For visualizing your data, you have separate operators. For clustering, you have separate operators. For model building, you have separate operators and so on. So that is why we are learning this tool in order to make this easy for everybody. This is about the next one, that is DB scan. Next what? The next one that we have, the last one that we have discussed in unsupervised learning, that is association rules. What is the next one that we have seen? The next one that we have seen is association rules. So what is association rules? Association rules talks about the relationship, or it understands the relationship between items in a data set. So here, association rule, if you have any drawbacks, it will be overcome with the help of a process or a technique called as a priori algorithm, within which you have different types of performance metrics, out of which the first one that you have is support. What is support? Support is one of the performance metric present. Here, it talks about frequency. So always in this concept of this performance metrics, there is a concept comes in, that is probability, which we have seen before. Probability is nothing but it is a way to measure how likely something is going to happen, which means I can simply write it as number of interested events divided by total number of events. This is the formula to calculate probability. So how to calculate support for this particular association rules a priori algorithm? So support formula is taken as, before talking about the support, we have to understand the terminology, that is antecedent and consequent. We have to understand about the terminology antecedent and consequent. So if ever we are measuring for if antecedent and consequent, this particular case here, if part is called antecedent and then part is called as consequent. If I want frequency or support of A, which is appearing together with C, if I want to measure or if I want to find out the support, the frequency of antecedent that is appearing together with C, consequent C, then how can I calculate? What is the formula? The formula is number of A and T together divided by the total number of transactions or records present. This is the formula for the performance metric, that is support. And the second one that we have is another performance metric, that is confidence. What is confidence? What is the use of confidence? So confidence talks about how independent antecedent and consequent are. What is it? The confidence usually talks about, or it captures the how independent antecedent and consequent are. Now, what is the formula for this? How to calculate the confidence? That is, the confidence to calculate A appearing together with C is number of times A and C appearing together divided by number of transactions of A. This is somewhat different compared to confidence and support. And then the next performance metric that we have is lift or lift ratio. So lift or lift ratio, it captures the ratio between how independent antecedent and consequent are and how dependent antecedent and consequent are. Now, what is the formula for lift ratio? How can I calculate lift ratio? Lift ratio is nothing but confidence divided by benchmark confidence. Confidence divided by benchmark confidence. So confidence, you already know about this formula. That is this one. Then what about the benchmark confidence? How can I calculate benchmark confidence? So benchmark confidence is calculated by the formula number of transactions or number of times consequent is appearing divided by total number of transactions. So if I want to find out the lift ratio formula, I have to divide confidence by benchmark confidence. So what is the formula of confidence? That is this one. So number of times A and C appearing together divided by number of transactions of A divided by what is benchmark confidence. This is your benchmark confidence. Total number of C transactions divided by total. This is your formula to calculate the third performance measure present, that is lift ratio. Lift ratio captures the information about the ratio of how independent antecedent and consequent are and how dependent antecedent and consequent are. Apart from these three, support, confidence, and lift ratio, you have the next one, that is leverage. What is leverage? How can I calculate this one? Leverage, you have a formula. This is the difference between the frequency of A and C appearing together and the frequency of how independent two items A and C are. So support of A and C minus support of A into support of C. This is the next performance measure, that is leverage. And the next one that we have is conviction. Conviction is again different measure. So this can be calculated by the formula 1 minus support of consequent divided by 1 minus confidence of A and C appearing together. This is the formula for the another one, which is conviction. This is how we will just understand the concepts here in association rules. Now, fine. Association rules is fine. We have different types of performance measures. That is also fine. Now, how to perform this in RapidMiner Studio? How to perform this in RapidMiner Studio? Which operator I have to use in order to work with RapidMiner Studio? So here, let me go back to the application. So here is my RapidMiner Studio in which we have done or used the operator dbScan before. I'm going to delete this process. I've deleted this process. Now I want to use the Excel file that I already have, which I've created specially for the association purpose. So see here, that is an Excel file. So I don't want to save it in my repository panel. So I will use the operator read Excel. So how to load my data into this particular operator? Double click on this operator and choose the file that you want to work with. We are currently working on the concept association rules. So I will click on association rules and next. And check it out whether your formatting is present there properly at the bottom or not. So this is properly there, but I want to check whether I need all the columns or not. If you check it out here, A column is not properly formatted. So what I do is I will select only from B to H. I don't want A column because that is not proper. That is not in proper format. Okay, B to H is fine. Now click on next. If you check out at the bottom, there is no problem in formatting of my data set and I don't want to format any columns. Whatever that is there, that is fine. So I'll simply click on finish. Now I've got my data. In order to understand the data, what you do, you have to execute your process. So see here, I'm connecting this to the response port and I'm executing my process. So totally there are 350 number of records and 7 regular columns, regular attributes. And then what? Everything here is present in numbers, numerical only. Now, I don't want to calculate or I don't want to consider this particular data or column called as TID. That is nothing but rows. Okay, so I have a column called as TID. I don't want to specify this column because this is just in the form of row numbers. So what I do is I will use the operator called as select attributes. So why I'm using this one? Because I don't want TID column to be used in association purpose. So here I will exclude only one attribute, that is what? TID. So this is the one that I want to exclude. Now execute your process, you won't get that TID coming. So out of 7, I have only 6 columns now. Okay, now everything is present in numbers. I don't want it in numbers. I want only true or false. So what I do, I will just use the operator numeric to binomial because I want only 2 categories, true or false. So I will use the operator binomial. I will not check out anything. I will not change anything in parameters. I will execute the process. So out of 0 and 1 now, it is converted into true or false here. 0 is false and 1 is true. And after that, the main concept of ours is we are about to discuss about association rules. For association rules, here you have a specific operator called as FP growth. What is the use of this operator? You have to check it out. You want to check it, you can check it like this. Go to description. This operator calculates all the frequently occurring item sets in the example set, which means in the data set. So frequency is talked about with the help of which performance measure? That is support. So take this operator. You can check it out. What is the minimum support that you want? Maybe I will check it out to 1. Okay. FP growth is fine. Now, if you want to create the association rules, what is the operator? That is create association rules is the operator. Take that into the process. If you want to check out the confidence value, or if you want to check out the other values, you can check out here. I will not replace anything here. This is fine. And I'm just establishing the connection here properly. So I will just connect this here. FP growth example directly needs to be executed. And I will just check it out here. And I will take the second one here. Frequently occurring items to create the association and execute this process. So you have to establish the connections properly. So this is the Excel file which I have created, which is having association data. Everything is present in zeros and ones, out of which I don't want to consider a column which talks about only the row numbers. So I'm excluding the columns using the attribute or the operator called as select attributes. And I'm converting all the numbers present into true or false, which is binomial. So I have used the operator numerical to binomial. And in order to talk about or select the frequently distributed items, I can use the FP growth. In order to create the association, I can use the create association rules operator. Once the connections are properly present, execute the process. Once this is executed, see here, this is numerical to binomial output, which is zeros and ones are converted into true or false. And this is your association rules. How much is the support? How much is the confidence? How much is the gain? Lift ratio, conviction, everything is present here. And after that, you have FP growth. So out of whichever the support value is high, that is the one that you have to choose more, the frequently occurring items. So here, if you observe, skirts and blouses are bought together because it is having high support. This is how you can talk about the concept called as association rules and the operators that you can use, create association rules, FP growth, etc. depending upon your purpose. This is about something called as unsupervised learning algorithms. So up to now, what did we discuss? We have discussed the first thing, that is unsupervised learning. So what did we see? Just we will get into the mind map. See here, model building. It is also called as data mining or machine learning. You have